Well, hello, everybody. So we're on module 7, which is very exciting. So we have module 8, which will be thermal processing next week, and then Thanksgiving, and then packaging, and we'll be done with the food science class. So very exciting. I did hear from John. He's not here yet, but I think he has a exam date of the 19th, so we'll have to be sure and quiz him when he comes on. So, which is coming up soon. But he did really well on the sample test, so he should be just fine. So, upcoming classes, and talked about that. December 11th. So, my dates toward the end of the year always get a little sketchy. So, but around December 11th, if you could have the final exam done by then, and get it over with before the holidays. And then I hope to send out the certificates in early January. So you can watch for those. And then for those of you who might be interested in taking culinary arts or taking it over again, we'll start on January 15th. So not too many people take culinary arts. It's kind of the least popular of the classes, but there are always few. And if you know anybody who's interested in starting to take the classes, I really recommend they start with culinary arts because it's the easiest of the classes. And so they can get into the swing of studying and into the swing of how things go. So if you know anybody who wants to start, just let me know. I noticed that a lot of you are using Google for answers. And while that's fine, and AI is wonderful, and it comes up with usually the right answer, especially for our kinds of stuff, but just in case, do know that the questions on the exam are listed to that which we can find in the culinology and the on cooking books. So don't go down the rabbit hole, right? Don't overstress yourself, right? I don't mind that you use those things to help you answer the questions, but remember always to come back to the learning objective and to answer the learning objective. Try not to go crazy and go down the rabbit hole, okay? Just kind of make your life a little easier. I noticed that a few of you joined the class after I started, so if you would write your names in the chat, I would appreciate that so I can give you credit for attending. All right, so today we're going to talk about product shelf life. And product shelf life, I just want to cover hurdle technology just because I didn't cover it last week, or I didn't cover it when we covered shelf life. So do any of you know if you employ any hurdle technology in your processing? If you're too shy to say anything, you can put it in the chat. I see that Daniel and Brett and Ben are here. It's great. Welcome. Nobody? All right. Have you heard of hurdle technology before? Okay. So I'll bet you do use it, right? You just don't know it, right? It just hasn't been identified because I think we've been doing this for a long time. We just haven't really identified it. So we're going to talk about that. I'm going to talk about fermentation a little bit, just a little bit. And then there is this learning objective about food microbiology. And here I wrote out identify the parts and explain their function with the plant and animal cells, bacteriophage, which means bacteria, and viral. I wrote out what I think is the simplest of answers to that question. I do not believe that it's in the culinary or culinology or on cooking books, so don't spend a lot of time on it. And I think I put a document well, I know I did, in the learning objectives, in the questions. So you can use that as well to answer some of the questions. But don't get too specific on it because, again, I don't think it's in the culinology text. Dog's here. Uh, oh, but that's my neighbor's gardeners. Yay, right on time. Uh, let's see. Anything else? Anybody have any questions about any of that? Okay. So what is hurdle technology and why? Why do we worry about it? Or why do we need to know that? It's actually a relatively new concept. And the objective is that if you did a lot of little things, you could control the pathogen or the microbe that's growing without destroying the food. So if you do a little bit of washing and a little bit of cooking and control the water activity a little bit, you don't have to do all of that, right? You don't have to do all of it at a really high levels. And so that we can maintain the quality of the food. So the example that I have right here is these are two newer processes that I found, but essentially what they are doing is using hurdle technology. So in this one here, they're blanching. Can anybody tell me what is the purpose of the blanching?
It inactivates enzymes.
Perfect, Ben. That's right. So this happens to be a processing for peaches and apricots, which brown, right? So that's right. So it inactivates. The heat is going to inactivate the enzymes. So the enzymatic browning is not going to happen. Then there's water activity. So what in this particular one, they're going to control the water activity, osmotic dehydration. So what are they going to do with osmosis? Osmosis is when it when the water moves from the area of high concentration to low concentration. So what they're doing is they're pulling the water out. So it's going to be a little bit stiffer. It's going to be a little bit less water. Then they added a preservative. In this particular case, they added ascorbic acid solution. And if you remember back when we talked about enzymatic browning, we talked about that fruit fresh stuff. And that's what that is. So we're going to add a little ascorbic acid as a preservative. And then they're going to do some high pressure processing, which is high pressure processing is like how they make the packaged guacamole, right? The one, So essentially what they do is they put it in a big tank of water. The avocado already packaged, they put it in a big tank of water, and then they increase the pressure, and that pressure destroys any pathogens that might be there. And then they're going to package it, right? So they're going to package it, and then they're going to recommend that it be stored at the refrigerator temperatures. So the same sort of thing is going on here. This is fresh cut apples. So they're going to wash the apples in a chlorinated solution, add a little acid, some edible coating on the outside to keep the oxygen out, and then use pulse light to destroy any bacteria that are going to be there, and then store it in the refrigerator. So you can see that essentially what they're doing is they're asking the bacteria to go over this hump and this hump and this hump and this hump. And so we don't have to dry it all the way until it's like brittle, right? And the water activity is really low. We don't have to cook it a lot. So each one of these is a lower level of processing. Any questions about hurdle technology? So after what I've talked about, can you think about any of your processes and can you see where you might be using maybe not different 4 or 5 different levels, but different levels for your processing?
Well, I think we at least sort of vacuum pack things and freeze, I guess freezing counts, right? Stopping something from spoiling. We're slowing it.
Yes. Right. Okay. So what do you do to you what are you vacuum packaging?
Um, am I muted still? Meat like cooked meat products
Okay.
or or even raw, actually, raw and cooked meat products.
Okay. So essentially what you're doing, you're processing, you're cooking it, right? And then your vacuum packs is you're removing the oxygen. So the cooking is one hurdle, the remove of the oxygen is the other, and then you're storing it in the freezer, right? So you have multiple humps, right? So in that particular case, then you're preventing recontamination by packaging. So I don't know. Think about what you do a little bit, and I bet you can come up with a lot of different examples of how you are actually already using hurdle technology. But it enables us to sell fresher food without a lot of additives and things like that. It's one theory. Any questions? These are what some of the hurdles might be. High temperature, low temperature. I really liked what you said about Ben about slowing. So we know that refrigeration and freezing slows the action of enzymes, but doesn't necessarily stop them. So that's important to recognize. So redox is the removal of oxygen. When we talk about pathogen control, and I just sort of threw this in, this is a really great chart that really explains the main four categories of food processing as recognized by the federal regulations. And it's all based on water activity and pH. And remember that I told you that that it's important to know these numbers. And so these numbers are the clue. So low acid foods. So what would be an example of a low acid food? A food that has a high pH.
Vegetables?
Right. Canned vegetables, particularly, is what they're talking about here, right? So they are not acidic. I don't know why they call it low acid. I always have trouble. I always have to think about that word. But okay, so what do they have? They have a pH higher than 4.6 and a water activity of greater than 0.85. So this is, let's say, canned green beans right here. If we add an acid to that, so let's say this is the cucumber, and now we add an acid to it over here, right? So now we have a pH of less than 4.6, but it still has a high water activity, and that's called an acidified food, and that is shelf stable because we have lowered the pH. So an acidified food. We can also have a water controlled food. So this would be dried, right? Right here, dried, which has a pH greater than 4.6, let's say dried apples or peaches or whatever, and a water activity of 0.85. And remember that that pathogens will not grow below 0.85, but bacteria and molds may, but pathogens do not. And then we finally have an acid and water controlled food, which is totally shelf stable, right? Right here, maybe crackers. Well, crackers don't have a low pH. All right, so these are the four main categories of food processing. And how the food is processed is based on this. So we know that a low acid canned food will have to be retorted in a high pressure, in a retort. But that an acidified food we could process in boiling water, like, canned fruit. And the difference being is the difference in the pH. Any questions? You're so quiet out there. So anyway, I explained it all here again, so that in case you have any questions about what I said, it's all explained right here. There being no comments from anywhere. All right. Fermentation. Fermentation is the process of converting carbohydrates to alcohol or organic acids using microorganisms under anaerobic conditions. Not always anaerobic, but anyway, fermentation. So fermented metabolic process by which certain bacteria and yeast convert carbohydrates into carbon dioxide and ethyl alcohol. So this has to do with yeast breads, right? Here's some terms I think you probably are familiar with. Aerobic meaning those that thrive when oxygen is present. Anaerobic when oxygen is absent. Facultative means that they can do either or. So listeria, and it's the one in rice. Anyway, those two are facultative. They could grow with or without the presence of oxygen. The substrate is what they work on, and vegetative means growing. It's actually growing versus dead, I guess, vegetative versus dead. So just some terms that can be confusing. So let's talk first about bread, because that's the yummiest, I think. So bread is an ethanol fermentation. And if you've ever allowed a yeast bread to overrise, you can smell the alcohol in that. It's a byproduct, right? So what's going to happen is that the yeast is going to the starches and sugars are broken down by yeast into ethanol. So examples: beer, wine, bread. So yeast is a growing organism. So what kinds of things are going to affect the growth of yeast? Or what kinds of things are going to kill it? You can write these in the chat. What kind of things are going to, okay, nutrients. So Ryan, so what are the nutrients that we're talking about? Okay, sugar, water, right temp, salt. Okay. Okay, so the nutrients that we're talking about are carbohydrates, glucose. And glucose is going to produce ethanol and carbon dioxide. And when there's a buildup of ethanol, when there's too much, the yeast is going to stop growing. pH, maybe. So ethanol doesn't affect the pH, right? If we think about yeast bread, if we're making yeast bread, because I'm more comfortable with that than making alcohol. If we making yeast bread, right? If we get the yeast, if we get it too hot, what happens? The yeast dies, no bread, right? Well, it get bread, but it doesn't rise, right? If it's too cold, let's say we're mixing the yeast with water and it's too cold, it grows really, 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 really slowly. The same thing goes that when we're talking about proofing, if it's too hot, you can kill the yeast because they're growing things. If it's too cold, it takes forever for the yeast to grow. Once the alcohol content reaches a point where it becomes toxic, the alcohol will kill the yeast. So if you over ferment, the alcohol will kill the yeast. And that's actually what happens with beer and wine, because at 14 to 18%, there's too much alcohol and the yeast die, right? So, and then the carbon dioxide that causes the bread to rise is a byproduct of this fermentation. So this is a biological process. Questions? Maybe? Was that clear-ish? Yes? Mm, sort of, sort of, sort of, sort of. So if it runs out of sugar, so sometimes we put sugar in yeast dough. Why would we, other than to make it sweet, why would we do that? Why would we put sugar in the yeast dough?
Feed the yeast.
That's right. Yeah. So that's right, Monta. So it's going to start it off. But there's actually an enzyme in the flour, amylase, that's going to break down the amylose into the individual sugars. But that takes a while. So if we want it to start really fast, we put in a little bit of sugar. And that sugar then starts the yeast growing, and it grows really, really faster. Um, Salt. We put salt. Does anybody know why we put salt in a yeast dough?
Flavor to control the yeast growth.
Yes, flavor and to control the yeast growth. Right. That's what it's, well, that's why it's there, to keep the yeast from overgrowing. Okay.
There we go. We get the kings of wine, guys.
Yeah.
You gotta be able to talk about bread.
Right, right. Do you have anything to add to this discussion?
Yeah, come on.
Nope, all good there.
Oh, good. Oh, good. All right. That's true. I should be a little careful here. Some of you actually knows what's going on. Right. So anyway, so that's ethanol fermentation. This is the same thing that's used for alcohol to make beer and wine. Same process. There is lactic acid fermentation. So lactic, what do you think lactic means? What does lactic remind you of? What?
Dairy.
Lactose, dairy.
Yes, dairy, lactic, right. Okay, so that's easy to associate this with yogurt, not so much with sauerkraut, but and some of the others like pickles and kimchi and olives, but at least it gets you a start. So with the lactic acid fermentation, the name of the bacteria is lactobacillus, which sounds terrible. But here we go. Lacto, there's our lactic acid, lacto. And bacillus just means it's a rod shaped. That's all it means. It means that the lactobacillus is long and skinny. It's a rod shaped. Okay. So can be done by yeast and bacteria, converts sugars and starches into lactic acid. And that's how we get yogurt, because the lactic acid, right, denatures the casein in the milk and causes it to get firm. So the bacteria denatures the the casein, the protein that's in milk, and causes it to get firm. And that's how we get yogurt or kefir or any of those. They're similar to that. So what happens is we have the sugar, and the sugar is converted into lactic acid. The sugar, the name of the sugar, we already know this is glucose, but it says glucose here, but it could also be lactose, right? So it converts it into lactic acid. And from the lactic acid, water. Okay, so sugar, bacteria, lactic acid. And then the lactic acid works to to change the pH. And that's how we get cultured buttermilk, cultured butter, cheese, yogurt, olives, kimchi, and sauerkraut, and pickles. And summer
So
sauce. Yes.
Jill, just from an application perspective, I've I've made sauerkraut just by applying salt to cabbage. Right? I think that's how most of us, if any of us, have made it. And you just apply weight to it, and over time the liquid kind of rises, and it naturally causes whatever kind of fermentation, I guess, from the sugar inside of the cabbage. But where does the bacteria? Is the bacteria just airborne? Like how does that kind of stuff work?
Yeah, you don't add it, so it's just there,
Is
right?
there inside? Is it inside of cabbage? That just makes me wildly curious at it. Where the bacteria comes from, like specifically lactobacillus.
Yeah. I think it's just there. I think it comes from the air. I think
Okay,
it's there. Could you
cool.
remember the old story about how they got bread to rise, right? You know,
Yeah,
the very first starters, and the yeast was in the air, and so that's my guess.
yeah.
Anybody else? Anybody else? And I know you
Anybody
don't
know?
add it, so it must be just there, right?
Siri said that it's naturally on the surface.
It's
There
on
you
the surface, right? Okay,
good. Oh, good. All right. So it's just there, right? So, but that's what the fermentation process is. Yeah. Well,
cool.
that's a good question. Good question.
Hey, Jill, I have a question.
All right.
So on the homework, it says, under types of fermentation, and it says to list growth conditions under which they ferment. Like where in here is that the answer for that you just went through?
So, for this one,
Because in the text, there's so much on lactobacillus, and it's like, am I missing a simple answer, or like, is that answer going to be really long?
don't answer it really long, right?
Okay,
So,
yeah, that's
don't answer it really long. So, well, we look up here. I know I saw the answer in this one. So the for bread, right? So we could say that it's facultative. So facultative means that it can grow either in aerobic or anaerobic environment. So you want to identify that, right? Presence or
okay.
absence, right? And then another condition would be temperature. So it would
Mhm.
it grows at room temperature, people temperature, right? And then another condition might be pH, and so we know that it's going to be a neutral pH, and there's going to be
Okay.
water and be water. So if we look at the lactic acid one, it's aerobic. I'm pretty sure because it's not anaerobic, so it's aerobic, and so oxygen is available, so it's aerobic, right? And it's going to be controlled by pH. So as it becomes more and more acidic, it's going to be controlled that way. And since it doesn't say, it's room temperature. Okay.
Okay.
And I think that's that's all you need to know. You would want to know the name, lactic acid fermentation, and you'd want to know like yogurt and sauerkraut. You want to know what it makes, right?
Yeah, it says list the food products and then list growth conditions under which they ferment and then the cycle that the fermentation undergoes.
Yeah. So keep it short. Keep it
Okay.
short, right? Okay. And then we look at acetic acid fermentation, right? That's the conversion of ethanol, which is alcohol, into vinegar. Right. So that's what we're getting. We're getting alcohol into vinegar. And it's a two-stage process. To be type of acid product. Okay, so first it ferments to produce the alcohol and then the conversion. And if I'm not mistaken, oh no, I am mistaken. It's aerobic, right? I think it happens at room temperature. The name of the bacteria is Acidobacter Acidobacter. So, but if we break that off, we can get acido, which is close to acetic acid fermentation. And room temperature. And then there are a couple others. It's a little vague, but there are two. It says list 5. And the learning objective is so frustrating. It says talk about these 3 and then 2 more. Well, which 2, right? Right? 2 more. How do you know which 2 more? So I picked alkaline fermentation bacteria. So and this one is from to make natto. So it's, and then the reason I picked this one is because it's basic. All the others are acidic. And again, bacillus means rod shaped, and these are the names. You don't think you need to know those. And what happens is you do need to know that it's hydrolyzed. Hydrolyzed means break apart with water, right? Into amino acid, protein into amino acids and peptides. So I think this one is a good one to know because it's really different, right? So what you get is, it just sounds so yummy. Pungent, slimy, petrofactive, yucky tasting things, right? But alkaline. So if you can think about alkaline and remember that when we talked about amino acids and proteins, right? We talked that they had an amine group. This could be either NH3 and an acid group. So this is the only, proteins are the only one with an amine, that they're the only ones with nitrogen in them. So you can associate that. So remember that a protein, amino acids are long chain, the proteins are long chains of amino acids cooked together, and peptides are just 10 or less. So the same thing, long chains. So I think this one's kind of nice. We don't have a lot about what's going on, but at least I didn't pick it up, right? But the pH is going to be neutral. So the pH of all the other ones is going to be much higher. So if I ask you something basic or neutral, this would be one to look at.
Sounds like a great thing for your packaging, putrefactive.
This sounds like just the kind of thing I'd love to eat. Blech. Right. So obviously it's a cultural thing, right? Fungi and molds also will do that. So and they are salt tolerant. So fermentation of vegetables like tempeh and mold fermentation cakes. We can ask Anna about these, right? Do you guys in the Philippines, do you eat any of these things like the what was it? Tempeh or a mold fermented soybean?
I think it's not in our country, Jill. I think it's in Indonesia,
Oh,
the tempe. Yeah, I think in our country, what was mentioned in the textbook was puto. So puto is a rice cake. So it's similar to bread, but we use rice flour.
ah, okay.
Yeah, and coconut milk.
Ah, okay.
Yeah.
That doesn't sound too bad.
And we add yeast or any leaveners and steam it instead of baking.
Oh, okay. And do you know that yeast is a fungi, right? Is that right? I think so. Not a mold, so it's a fungi. So you can kind of say that these are very similar to the yeast that we talked about before. Oh no. Um, but I would, when I'm studying this, I'd pick up 3 or 4 facts that make it special or unique, and I would go with that. Any more questions or comments? Oh, great, Monto. Fermented shark. Yum. Monto, put that in the discussion. Okay, so let's get out your pens and let's see how bad. Oh, lutefisk. Yum. What about what are the juicy, the gefilte fish? Is that fermented? I don't think so.
I don't
Um,
think that's fermented. Yeah.
Don't they use lye to process that?
Is it
Maybe
filter
I'm
fish?
thinking of something else. Maybe I'm thinking of something else.
no
Yeah,
meat.
I think a filter fish is just like essentially like a farce meat that's poached.
Yes, you're right. You're right. It is. And that I don't know, in my world it comes in a jar.
It can if you don't make it from scratch. It can certainly come in a jar. Yeah.
Comes in a jar, right? Right. Okay, so let's get out your pens and let's see how we can do. Let's start with the acetic acid fermentation. So looking at that, can you match it up with which of the following terms? So which of these can you associate with acetic acid fermentation? Okay, vinegar, yeast. We're just doing acetic acid. Okay. Okay. Acetobacter, very good. Vinegar, very good. Yeast and bacteria. All right. Very good. Okay. Any questions? I like what I'm seeing. So, all right. Oh, be that way. All right. So, ethanol fermentation. Ethanol fermentation, yeast breads, yeast waste products, starches and sugars. Very good. That's the easiest one, right? Ethanol fermentation. I should have put beer and wine. Okay. Questions about that? I like all the pretty colors. All righty, the lactic acid fermentation. Yogurt, sauerkraut, lactobacillus. Great. Okay, great. Well, we could put the sugars and starches in there too. Okay, very good. All righty. So like I say, I wouldn't spend a whole lot of time studying this stuff, just do the best you can. create kind of a chart, right? Create a chart. Oh, okay. So kind of to summarize, so fermentation requires a bacteria, fungi, or a mold. Microorganisms are living things. They are living things. So that means we can kill them, right? Living things affected by their environment. So a pH below pH of 4.6, they will die. So the pathogens will die below 4.6. Water activity, there has to be water for these bacteria to live and grow and to move around. So I think these numbers are important. Yeast and mold. I don't know why this says 9. I'm going to change this. So there's one of my quiz questions that said 86. I think if we read it carefully, that would be 86 and above and 85 and below. But at any rate, right. So including pathogens need water. Yeast and molds. So you can see that, don't have that chart here. Oh, I see why this was a 90. I apologize. We'll leave it. The FDA guideline is 0.85. That's because it's significantly lower than 9. So a margin of safety in there. Okay. Anybody have any questions? Okay. So each microorganism has its own personality. So depending on what you're going to do, they have different requirements for water and pH and temperature. Sanitation is very important because we don't want any strays coming in. I once had a guy do a presentation and he was talking about, I think, shelf life or something. And he said to me and the class, he said, if you have problems with yeast or molds, check your environment. So just like we were talking about the sauerkraut, that the lactobacillus comes from the air, it could be in your heating or air conditioning system, but somehow it's blowing around inside your facility. So don't necessarily think it's just the food's not being processed right, but it probably means there's some kind of recontamination after processing. So that's what he said. I thought that was useful. I think you guys know the bacterial growth curve, right? Yeah, right. From your pathogen studies, right? So let's talk a little bit about microbiological testing. So the most common ones that I think you need to know are the aerobic plate count, the coliform, and the E. coli count. And these are indicators. So the aerobic plate count is just what it says. It says, what is flying around in the air, right? So usually they just take a petri dish and they put it out in the, they put it out and see what flies in. So the aerobic plate count. So it gives you an idea about the bacterial level in your product. but it doesn't tell you what kind. It could be anybody, right? So sometimes it's called the total plate count, standard plate count. But if this is high, then it means you need to look farther, right? It can also be a quality of freshness. Okay, so that's the easiest one. The next one is coliforms. So coliforms are a group of bacteria that originate in the soil, think the coliforms, right? They're common in the environment, and they have to do with sanitation. Again, they don't tell us what's particularly what coliform, it just tells us that the whole group is there. We can also test for E. coli, which is non-pathogenic. And it usually means there's a sanitation issue, fecal oral sanitation. So because it comes out of the gut of warm-blooded animals. So they can test for E. coli. There are lots of different E. coli, and there's only one really that causes illness, and that's the E. coli, the only pathogen really. But if the other ones are there, then that's a scary that we could possibly have others. And so if this is a problem, then you need to look at the human sanitation, people taking off their lab coats before they go to the bathroom. Is everybody washing their hands really well, right? Are you making sure that there's a separation between the processing room and the packaging so that there's no cross contamination? So it usually means that there's a sanitation issue. And then there are a bunch more of tests, but those are the most common tests: the aerobic plate count, coliforms, and E. coli. And they're mostly done with a petri dish, or the old ways. So if you want, I used to use these in my classes, and they were kind of fun. They're really easy to use. And so what they are is a little bit of growth medium on a piece of paper. And I used to go around and like swab things in the lab, and then I'd stick them up over my desk because I didn't have any way to incubate them and stuff like that. But I'd stick them on the cabinet above my desk. But they're made by 3M, and they're relatively inexpensive. And so if you wanted to do some testing without getting a lot of elaborate equipment, you can use those. So I just put them down there at the bottom.
Sometimes those things smell horrible.
Yeah, well, I used to keep them for a week too, right? Because that's how long we had to keep them for the week for the class. So have you used these, Monto?
When I used to grow, we're kind of testing now because they're legalizing psychedelic mushrooms. So we're working on using those for like a similar system for replicating. So we're going to get some to kind of check our environment to see if they're just to test our clean box and stuff. So I haven't used them yet, but will be soon.
Yeah, yeah. They're not very expensive, are they?
I don't know. That's kind of the person I'm working with's domain to get them. So I can find out what they paid.
Right. I used to get them to give them to me, so I don't really know how much they cost, but I don't think they're very expensive. They used to send them to me for free because I whined, because I was a teacher. So, but yeah, they work pretty well. So there are some other ones too. There are some that come with like a swab and all that. So they're pretty cool actually. If you don't have the facilities to do some real testing. So,
Maybe if I say it's for class, they'll give me some for free too.
ha. Don't
You
use
definitely have a better chance at that than saying they're for psychedelic mushrooms and getting them for free. You know what I'm saying?
Right. They'll tell me not even gonna sell them.
Yeah, I don't think they'll answer your call the next time.
All righty. Well, I don't know. Does anybody have any questions about anything? Do know this. So if you haven't pathogens, right? Remember the pathogens, there's two different groups of microorganisms. There's the pathogens, the ones that make us sick, and the spoilage organisms. Fortunately for us, the spoilage organisms are a lot more vigorous than the pathogens. So oftentimes we'll say, could it spoil safe? So if it spoils, if it smells bad or if it gets really sour, right? Or watery or whatever. So those are the spoilage organisms, and they're a lot harder to kill than the pathogens. But the pathogens, um, these are the growing conditions for pathogens. So we should know about that, right? So pH greater than 4.6, water activity greater than 0.85. They're mostly aerobic. Does anybody know which one is anaerobic?
The spores for botulism.
Right, right. And so that would be in low acid canned food. But I just there's a withdrawal recently for baby formula, right? A powdered baby formula. So for infantile botulism, but that one's a little bit different than the one that's in the low acid canned food. So, but super scary. Anyway, and then the food source is generally a carbohydrate. So if you have a food that's really low in carbohydrates, you don't have to worry too much about this. So they don't like to grow on proteins and nothing grows on lipids. Yeah. But know these, I think these are important parameters to know, just to put them on a little flashcard so that you know those. But I've been repeating this over and over and over again. So by now you ought to, right? You ought to know, right? So, okay. Anybody else? Any questions?